In question 19, I want to highlight that I want you to draw a graph for a 2-day period. So what happens, David, he drives to work in the morning, so he's going to stay at work for a while, and then he's going to come home for lunch. Okay, you got to come home, so my x-axis is home. And then he goes back to work, and then he's at work for a while, then he goes to the gym. Now the question is, the gym, you have a choice. Is the gym farther away or closer to his home? Let's say it's further away. So he's going to drive from work, he's going to go to the gym. He's going to stay at the gym for a while, then he's going to return home. Then I want to do is I just want to repeat this graph twice. And notice I didn't do a very good job here because I ran out of room. I should have made my steps closer, but that's about what we do. Question 20. Is that a function? That is, for every value I put in for x, how many answers for y am I going to get? Well, it seems I'm going to only get one answer because I'm not doing anything weird. So this would be a function because there's only one answer. Only one output for each input. I can also graph this to see what it looks like. So if I go to my Desmos graphing calculator, which I got to open up, it looks like, and there we go. So I'm going to go 1/2 x. Come on. There we go. So I go 1/2 x. And the rest of the question is plus 4y equals 6. And it looks like it's a line, isn't it? For every input, I have exactly one output. So I'm at -10, only got one answer there. Okay? And I'm at -2.76, I have one answer, and so on. So my assumption, or my guess, was most likely right. Now if we take a look at question 21, this is just like from your assignment. I want to, well, that's not quite from your assignment, but very similar. So I'm going to take 2 times f of r. So I'm going to find, first thing I want to do is I want to find f of r. That's pretty simple. We just replace 2 with x. So I say, or r with x. So I go -3 times r squared minus 2 times r plus 1. Well, to find 2 times f of r, I just take 2 times my previous answer. -3r squared minus 2r plus 1. So I get -6r squared minus 4r plus 2 is 2 of f of r. Now if I take a look at 22, what's the meaning of the y-intercept of my graph? My y-intercept is at the beginning. The meaning is, well, that would be the population in 1900. When you have questions like this, we're not so concerned, or I should say, don't read more into the question than I'm asking. I'm just asking for the y-intercept. I'm not asking you to describe the whole graph. I'm not asking for the x-intercept, just the y. I'm not even asking what the y-intercept is. I'm just saying, what does it mean? Now, on 23, we want to interpret the end behavior of our graph. Our end behavior means what's happening as it gets bigger and bigger. Notice it seems to be approaching 15 million. So I'd say as The years increase. The population will approach 15 million. And the reason it doesn't keep growing forever is because think about what you need to have in order for the population to increase. You have to have land, you have to have water, you have to have jobs for everybody. You don't want everybody living in poverty. So there's a natural point or a maximum point. Now you don't have a behavior to the left because time can't be negative. So there is, I guess we could say it starts at a little bit under 5 million, but that's really not what I consider end behavior. End behavior is what happens as it keeps on going and going in one direction. And that's what we do in that question.